Have you ever really thought about what's going on under the hood of your car? I mean, yeah, there are explosions and gears, but there's also this silent, super complex dance happening every single second the engine's running. Today, we're going to pull back the curtain on this incredible, invisible balancing act. And you know what? That's the perfect way to describe it. Your engine is literally walking a tightrope, constantly making these tiny, microscopic adjustments to hold a perfect balance between air and fuel. So why go to all this trouble? What's the point of this whole high-wire performance? Well, there's your answer. The whole show is for one single very important audience member, the catalytic converter. This little box is your car's #1 weapon against pollution. It takes nasty, toxic gases and turns them into stuff that's way safer. But here's the catch. It's incredibly picky. It can only work its magic if the exhaust mixture it gets is just right. And that just right mixture has a very specific name, stoichiometry. Just think of it as the dead center of that tightrope. It's the chemically perfect recipe of air and fuel. If you lean too far one way, you get unburnt fuel spewing out. Lean too far the other way, and you're creating all these nasty nitrogen oxides. The engine's whole job is to stay right on that razor's edge. So who are the performers keeping it there?
Okay, let's meet the crew. It's a small but highly specialized team, and each member plays an absolutely vital role in making sure this balancing act never fails.
First, you've got the Scout. This is the front oxygen sensor, and its job is to be right there in the exhaust, sniffing the fumes. Then you have the Brain, which is the engine control unit, or ECU. It's the shot caller. And finally, you have the Muscle, the fuel injectors, and they're the ones who actually do the work. And it all works in this really simple, continuous loop. The Scout sends a report back to the Brain about what it's seeing in the exhaust. The Brain analyzes that report and then immediately barks an order at the Muscle to add a little more or a little less fuel. This happens hundreds, sometimes thousands of times a second. But the really fascinating part is the Brain's surprisingly sophisticated strategy for making those decisions. So how does the Brain actually think? How does it process all that information from the Scout to make these lightning-fast, super precise calls? Well, it's clever. It doesn't just look at the data one way. It uses a two-part strategy to see both what's happening right now and what the bigger trend looks like. Okay, this is where it gets really, really cool. The Brain takes that single stream of data coming from the O2 sensor and basically splits it into two different views. One is fast and chaotic, and the other is slow and steady. The fast signal is that raw, moment-to-moment data. It shows every tiny twitch and fluctuation, which makes it perfect for quick, knee-jerk reactions. The slow signal, on the other hand, is filtered. It smooths out all those little blips and shows the underlying long-term trend. This is what you need for making thoughtful, strategic moves. Now, using these two different views of the world, the Brain deploys a correction team that has two totally distinct personalities. Think of one as a reactive sprinter and the other as a patient, long-term strategist. So let's meet them. You've got the sprinter. Its technical name is the proportional term, and it uses that fast signal. Its job is to make big, immediate changes to yank the air-fuel ratio back towards the target as fast as possible. Then you have the strategist, the integral term. It looks at the slow signal and makes these tiny, gradual tweaks over time to erase any lingering errors and really dial in that perfect balance. So let's see how they work together. First, the Scout yells, "Hey, we're off balance." The sprinter immediately jumps in with a big, fast correction to get back on the tightrope. Then the strategist watches how things are going and makes these little, gentle nudges to get absolutely perfect. And that cycle just repeats over and over and over, keeping the engine locked right on target. But here's the thing about this crack team. They don't just work 24/7. It's a really smart system, and it knows that to make good decisions, it needs good data. So it follows a very strict set of rules about when it's allowed to even start working. So this system operates in what's called closed-loop control, which is just a fancy way of saying it's actively listening to the O2 sensor. But sometimes it has to switch to open-loop, where it ignores the sensor and just relies on a preset map of what to do. And it does that anytime it thinks the sensor's data might not be reliable. So when does the team actually go on duty? Well, a few things have to happen first. The engine has to be fully warmed up, and the O2 sensor itself needs to be hot enough to work right. There can't be any major check engine light type faults that could confuse things. And the car can't be in some weird state, like you flooring it to pass someone or taking your foot off the gas completely, because in those moments, perfect emissions aren't the top priority.
And the logic here is just plain common sense. Garbage in, garbage out. The brain knows that if it tried to make adjustments based on data from a cold sensor or during some extreme event, it would probably make things worse, not better. These rules are a failsafe to make sure the system is always precise and reliable. All right, so we've met the whole team, we know their playbook. Now for the grand finale. Let's bring it all home and talk about why this invisible, high-speed balancing act actually matters so much. You know, sometimes the engineers just say it best. A line from the technical documents says it all. This entire ridiculously complex dance of scouts and brains and sprinters and strategists has one single purpose: make the catalytic converter do its job as perfectly as it possibly can. So how well does it work? Well, when this whole system is running like it should, a modern catalytic converter can be over 99% efficient. I mean, think about that. 99% of the most harmful junk coming out of your engine gets neutralized, all because of this tiny, invisible control system. And that means the payoff for you and for everyone is huge. First, obviously, it means cleaner air for all of us to breathe. Second, because it's not wasting a single drop of fuel, it means better gas mileage, which is great for your wallet. And finally, an engine that's in perfect balance is a happy, smooth, and reliable engine. It's truly a win-win-win.
It really makes you think, doesn't it? This is just one of countless little feedback loops and control systems quietly humming away in the background of our lives, not just in our cars, but everywhere. So it's a fun question to ponder. What other invisible systems are out there, constantly making adjustments to keep your world running smoothly?